Welcome back. Today we're going to be covering 11.3 areas of circles. And with us today, we got Celeste and Alan, and we have Marcus. Max is absent today because he's doing his own Google Classroom. Now, let's go ahead and get started. Now, today we're going to focus on area as, yes, not the day before, but the very first video we did, we focused on what was arc area, just like you see there. It's kind of like length, you know. It's almost like, imagine that when you were back in elementary or middle school, they taught you perimeter, you know, like stuff that goes around distance-wise. And you also had the benefit of discovering area, which is the amount of space something occupies. Today, we're going to be working with area. So with that, Celeste, why don't you go ahead and read the first vocabulary term?
Sector of a circle.
Okay.
A region bounded by two radius and the blank arc in a circle.
Okay. Does anybody know what that blank is? The intercepted arc. And the reason why it's intercepted is this, just to kind of give you clarification and also idea what the solution is that this arc right here is being intercepted. That's how we know that it's stopping, like it goes from there to there. That's what intercepted means. All right. Hey, Marcus, go ahead and read the next one. Segment.
Okay. Segment of a circle. Part of a circle bounded by an arc and the blank joining the two endpoints of the arc.
Okay. Do you guys know what that blank is? Let me help you.
Segment.
Segment. Yeah. So this is in math terms. This is called a chord. Let me redraw it. That's a chord. That's a segment of the circle. Okay. And it's talking about this little area right here. That's the segment of a circle. That's what it's trying to talk about. Now let's go ahead and move down. And Celeste, why don't you go ahead and now do area of the circle.
Area of a circle. The number of squares that fit inside a circle.
Do you know what that is? That blank? Square units. So because remember, it's space that occupies the circle. So now we're going to go ahead and figure out how much space this occupies the circle. Now, do any of you kids remember the area of a circle formula? It's right here.
Yeah, pi r squared.
Yeah, pi r squared. When you do pi r squared, it gives us the benefit that we could now quickly get the area of the circle. So the only thing you really got to know is what r is. And if you're given the diameter, it's easy to figure out r, because all you do, diameter divided by 2 gives you the benefit of knowing what r is. Go ahead and make this smaller because it's way too big. Okay, good. All right, so now let's go ahead and talk about this keys concept. So when we first did the first video, we talked about length of a sector, right? And we spoke that in order to find not the whole circle, but to find a percent of the circle, we would go ahead and use this part right here, where we're looking for a fraction. Now, the thing that I would love for you guys to do is this next thing, okay? What's the only thing that's different from this equation to the one we did originally? Does anybody know what it is? Has to do with this part here, okay? This part that's highlighted, what does it give me the benefit of doing? You kids know what benefit I get from the highlighted portion?
More work.
Well, no, that highlighted portion is that this is the area of a circle. So as a benefit, I get the whole area of the circle. So see everything that I highlighted? Mm-hmm. The thing is that this little piece right here, and let me try to highlight it with something else. And I'm making it green actually. Is that the whole area of the circle? That green part?
No, it's only like a fraction of it.
It's only a portion, right? Okay, so in order to find that green part, that's why we use this part right here. Actually, let me do it in green to be consistent. That green part, I could go ahead and find it out because it's a fraction, okay? So just to kind of give you an idea, if I did 360 divided by 360, isn't that the whole circle?
Yeah.
all the way around, right? Okay, so I can have the benefit of finding the area of the whole circle because this is the area of the formula. But since I only want part of it, so let me hit undo. Since I only want part of it, I'm only going to put whatever that is. So Marcus, what do you estimate this is in degrees?
A third.
A third, right? So 120 degrees. So 120 degrees. This reduces to a third. So basically, whatever area you have here, you're going to multiply. You're going to find out what a third of it is. That's really what this formula is doing for us. Does it make sense to you guys? Before I move forward, because this basically is the foundation to these notes. So we're going to be basically just moving forward and using the benefit of using this equation to solve most of it. So now let's go ahead and go down. And now let's talk about, Celeste, why don't you go ahead and read key concept here. Oh, actually, you know what? I don't want to focus on this key concept. There's a better way to do this. So let's go ahead and move forward and actually just get right into the examples. I would love to do some examples with you to give us the benefit of actually using this. Now, the first thing we're going to do is that we're going to first find the area of each circle. And one thing that is important for us is that we're going to leave our answers in terms of pi. So Celeste, what does that mean to you when it says leave your answers in terms of pi? And let me highlight in yellow. What does this mean to you? Oh, Celeste, I can't hear you. Did you hit mute?
Yeah.
Okay, good. Okay, now go ahead and tell me again. What does it mean to leave your answers in terms of pi?
Like, so pi 2, and then it says like the number for the pi.
Well, I guess in order to clarify what you're trying to tell me, Celeste, at least what I get, is that when you solve, since our equation has pi r squared, we're gonna leave this guy alone right here. Or let me highlight it then. Oops. Yeah. Okay. This part right here, we're not gonna do anything with that pi. So all we're gonna do is focus on this part. And then we leave pi there next to it. That's what it means to leave it in terms of pi. Okay, does it make sense? So here, like, let's look at the first one. Hey, Marcus, tell me, how would I solve the area of this circle?
Okay, well, you'd first divide the diameter by 2 to get the radius.
Okay, and then how much is that?
4.
Okay, so there's 4 there, right? And then what do I do?
You do 4 squared to get 16 pi.
You get 16 pi, exactly. So notice how we got 4 square there? And as a result, answer is 16 pi. Now, they did go ahead and place the units, which is feet squared. All right, Celeste, how would I do B?
Well, B, you do 600. You would get 8.
How?
Well,
You take the diameter, Mama. Remember, the diameter is 16. You divide it by 2, and you'll get the radius 8.
that's what I thought it was.
Exactly. So hopefully now you can now quickly kind of state what's going to happen, right? Now, what do I do next?
You would do 8 times squared.
Okay, yeah, 8 squared pi, right? So what's 8 times 8? Quick math, Celeste. 8 times 8 is 64, right?
Yes.
So we'll write 64 pi centimeters squared. All right, Marcus, how would I do the last one?
You would divide 1/5 by 2 to get 1/10, and then you'd square 1/10 to get 1/100th.
Yes, remember when you divide by 2, keep in mind you reciprocate the fractions. So that means you flip-flop it, and this is how you get the result of 1/10. You see 1/5 times 1/2. And this might be new to you, Celeste, but it's important for you to know. And for everybody, it's important that's watching this video that it reminds them of what it is. All right, good. So then, and then what do I do next, Marcus?
You'd square 1/10 to get 1/100th.
Oh, great. Love it. Now, how'd you know it was 1/100, Marcus? What would you tell our audience?
Oh, you do 1/10 times 1/10.
Yeah, exactly. Good. Love the fact that you're good with fractions, because that gets you 1/100 pi. And then notice, hey, Celeste, let me ask you this question, because I know you don't see this often. Did the 1 disappear?
What?
The 1 is still there. Notice that? Just that in math, sometimes when it's not needed and it's assumed, they sometimes don't place it on there. Does it make sense?
Yes.
So this is one of the things that happens in math. All right, so now let's look at example 2. Celeste, why don't you go ahead and read example 2 for us?
Jerry has a lawn sprinkler that sprays water out into a circle. The diameter of the circle is 10 feet. What area can Jerry water with the sprinkler? Round to the nearest square foot.
All right, so they want to know how much we could water, right? We got a sprinkler. So in this case, Marcus, what would I do?
Well, you divide the diameter by 2 to get 5,
Good.
and then you would do 5 squared to get 25, and times that by, what, 3.1?
Yeah, 3.14. And so they get roughly 78.5, and they round that up to 79 square feet.
79.
Great. All right, now let's move on to example 3. Oh, good. Okay, so now this is when we're going to use a formula. Do any of you kids remember the formula so I could write it down for the people watching this video?
It was something like the measurement of an angle is blank blank over 360 times pi r squared, right?
So basically an angle, we're going to represent it as an x, O. Sometimes you also see the arc length on there because it's a central angle times pi r squared, which is the formula we've been working with to get the whole area. So in this case, like on the first one, Marcus, what would be the degrees? What would be the x that will go in there?
90.
Yeah, good. Yeah, it would be 90 degrees. So we're going to put 90 in here. And what else do I need to do?
For what?
To continue solving this.
You would replace r with 7 and simplify 90 over 360 to get 1/4.
Yeah, so then I get 1/4, right? And then that gives me how much? 7 squared is?
49.
Good. And in this case, how does 1/4 and 49 interact?
Well, 49 goes over 4. So you get
Actually, I think that could be reduced, can it?
Yeah, to 12 over 1/4, or 12.4.
Yeah, in this case, I'm pretty sure that this could be reduced because 49, well, actually, can 49 be reduced?
No.
Well, 49 does not divide into 2, right? So no, it's going to stay like this then. So then I'll be the answer.
You can just do 12.25 times pi.
Yeah, no, that sounds good. All right, so walk us through B. How would I do B? Celeste, do you have your phone on mute again?
Yeah, sorry.
Yeah, don't put it on mute. Okay, stop doing that. I need you to go ahead and just keep it open the whole time. You hear me? All right, good. Now let's go ahead and now do the next part.
Okay.
So how would I do this one?
How you would do that one? Okay.
Okay, so let's say you start with the equation. So you see this equation right here?
Yes.
Okay, we're going to start with the principal amount, which is this part right here. You see this x? You know where I get that x from? Right here. It tells me how much degrees it's going to occupy from here to here. Okay, so like that distance. Instead of the whole circle, which is 360, I'm only using what's in green. So what I'm going to do next is place that in there. So what is that going to look like? Like, what would you write down?
You do 45 over 360.
Yes. So you see like there, and then what would you do after that? Let me just a little bit. You see this part right here, this part of the formula, the R? Where do I get that from?
From the square.
Right here, from the 10. So you see how I highlighted both of them? So that's the amount that's going to go in here as the next step in solving this. So there's two things I'm going to do. I'm going to reduce 45 over 360 to get, well, actually they didn't reduce it. They went ahead and took 10, squared it to get 100. oops, hold on a second, let me go. This became 100. They took 100 and multiplied that with 45 to get 4,500 over 360 and then reduce that. And this is how they got, if you cancel out those zeros and you reduce, you get 25 over 2. Notice that? All right, good. All right, Marcus, go ahead and walk us through. Actually, let me give Celeste another chance. Celeste, walk us through the next problem. Go ahead and do B. No, C. Go ahead and do C. What do you do?
With the gray part or with the white?
The gray part, because I want to know the shaded area.
Well, so you do x over 360. You will get 300 over 360 because that's the
Good.
R.
And then what else? So you did this part. Now.
And then you do 6 feet for the R. Right?
Yes. Yes, because of that part right there, right? Good.
Yeah.
And then what do I do? Well, they multiplied it all out and then they reduced it. So that's how they got that amount. Okay. Now, one thing that I want to add, Celeste, that's important, is that originally when they did this problem, they actually didn't have this 300 stated on there. But notice how they got 60 right here?
But you would do 60 minus 300, well, 360 minus 60.
Exactly, and that's how they got 300. And that's how they were able to get that solution that I had covered up. All right, good. All right, Marcus, why don't you go ahead and let's do the next one. Well, let me move some stuff out of the way. All right, Marcus, so do the next one.
D?
Yeah, do D.
So are we trying to figure out the shaded area or the unshaded?
The shaded area.
Okay, so you would do 120 plus 180 to get 300 over 360.
Okay, good. And then what
and
else?
you would do 24 divided by 2 to get 12, and then 12 squared, which would be what, 144?
Yeah.
And then 144 over 1/6, no, 5/6.
Yeah.
Times 5 by 144 to get that big number, pi over 6.
Now, don't worry, Marcus. This basically is math they're going to be able to reduce on the calculators. The thing that's important is the steps. Now remember,
and yeah,
keep
you
in mind,
reduce it to get 120 pi unsquared.
120 pi, exactly. Okay, good. Now let's go ahead and do the next one. Now let's do this next problem right here. Now on this next problem, okay, they're gonna just give us information and then we're gonna be asked to input it in. So Celeste, why don't you read the directions first so we can make sure that's clear.
Find the area of sector QRS in the...
Yeah, it says just a circle R using the given information. And it says leave your answers in terms of pi. So in this case, Celeste, what's different about these problems compared to the ones we did? Well, the ones we did had pictures, right? Like these have no pictures. Now, if you wanted to conceptualize it, you're always free. You always have the power to draw it. So kind of like what I'm drawing. And you can go ahead and kind of estimate, like draw pictures. Like in this case, you want 135. 135 is going to be like that amount. Does that make sense? And this, and when I mean 135 is that the little shaded part. Let me hit undo to make this a little bit better. This little shaded part, that's roughly 135 degrees. Like if I go from here to here, that's 135 degrees. Now in this case though, is that they don't give us a picture. They just give you the information. So what would you do in this case, Celeste, to solve for A?
Well, you do 35 divided
You do 135 divided by what?
4.
No, what 135 divided by 360. Remember, this is M. This is that measurement that's there, the piece that I'm looking for. So I'll do 135 divided by 360. Still have my equation for circle right here because we're only going to find part of the circle. So what's going to go for R inside R's?
4.
Yes. So we're going to have 135 divided by 360 times pi 4 squared. Same thing, you do the math, you reduce, and you'll get this as a result. Okay, Marcus, why don't you walk us through the next one?
Okay, so you have the radius of 10 centimeters and a measurement of 90. So you do 90 over 360.
Okay, good.
And then you would times pi 10 squared to get 100
Okay.
pi. 90 over
Okay.
360 would be 1/4, which would be 400 over 4.
Yes. So I like your method, Marcus, because you kind of get to 25 pi quicker.
100 over 4.
Yeah.
Which is 25 pi.
Yes. Okay. Now let's go ahead and move on to the next one. And on the next one, let's go ahead and now do, all right, Celeste. Okay, Celeste, I want you to read this next one right here. Oh, thing was just moving.
What did you say, Daddy?
Read example number 5.
Find the area of each shaded segment. Round your answers to the nearest tenth.
All right, good. So then let's move over here to this other side because we could leave them. Now, look at the shaded area. So let's say, how's this different from the other times we've done it? Oops.
What did you say, Alex?
No, what is different about this one compared to the ones we did?
Well, the shaded part is a...
Yeah, this is known as a segment. This little shaded part right here. It's known as a segment. Now, there's a special way to solve for this one, so I'll go ahead and do it for you. The special way to solve for it is this way, okay? You find the area just like we had been doing it. So you know how we were finding area of the whole thing? So basically we were finding this whole place. Let's see, let me show it right here. We're basically finding this whole area, right? Now what we're gonna do is we're gonna subtract this triangle from it. And we could subtract it because we do know what the base and the height of this is. Now, Marcus, how would I know what I know what the height is. How do I know the base?
Well, I don't know how to prove it, but the thing just looks like half a square. So it'd just be 10 for height and 10 for base.
Kind of, right? Okay, so this is a radius, right?
Yeah.
Now, remember, this is
so it has
also a radius, right?
The radius. Yeah.
So it's basically 10 as well
10.
as a benefit. So anytime you see a triangle there, you could just automatically assume it. So I have base, I have height, and I also have R, which is also 10. Now, it's convenient that they're all actually 10. So as we walk through this problem, I could quickly show you that we know that this is 90 degrees.
Mm-hmm.
So I'm gonna have 90 over 360, and then I filled in the R. Let me go to pen. I fill in the R here. I fill in my base. Okay, let me go to the bigger one. I fill out my base here, and then I fill out my height here. Does everybody see all that? So as a result, once I do the math, I'll figure out that this is really 9,000 pi divided by 360, and subtracting 100 over squared, which is the area of the triangle. So I'm gonna get 25 pi minus 50, and then I could go ahead and round it. Y'all see that? Okay, does it make sense? Okay, good. Now, so let's move on to example 6. All right, now on example 6, Marcus, why don't you read the directions to us? Hold on, let me move this over here.
Find the area of the shaded region. Leave your answer in terms of pi and in simplest radical form.
All right, good. Now I'm gonna go ahead and I'm gonna start with A, but I'm gonna open this question to both you, Celeste, and Marcus. Do any of you two kids know how to do A?
Oh, well.
Oh shoot, hold on a second. I'm trying to scroll it down so I could show. There you go. Okay, so do any of you two kids know how to do A?
Well, I think so, but it seems really long.
It can be. Now there is a shorter way.
Yes.
First of all, what is the, let me show you the shorter way. can I find the area of just this part here?
Yes.
Okay, how would I do that?
You'd do pi 12 squared times the measurement. What is that? 270 over 360.
All right, good. So for everybody listening, I love the fact that you told me all the solutions, Marcus, but you lost some people. And the reason being is this. So you figured out, first of all, or it was given to us that was 90, right?
Mm-hmm.
So as a result, that's 270 degrees, right? The shaded
Yeah.
area, because it's 360 minus 90. And the next thing you did is that you went ahead and quickly discovered that R was 12, which was also given to us. But in the placement of this whole thing, these are all the things that sometimes you have to sit back and look at the circle and say, okay, you said all this, but be able to put it down, especially for those that need some time for this to really sink in.
Okay.
Now,
Yeah.
yeah, so, but the thing that I love is that we got all the data now. So what we're gonna do next, okay? So I'm gonna find the area of the green region. What's the best way to find the area of, hold on a second, I'm trying to go back to the highlighter. Got to give this smartboard a second because it's thinking about it. Like it doesn't, oh, you know what it is? My pen turned off. Hold on. I wonder. Okay. All right. Now, how do I find, I'm going to do it in blue. This little, what's the best way to find this little area here?
Oh, well, you just do the same thing we did with the other one. You'd find the area of the triangle by
Yeah.
doing 12 times 12, which is the base and height, over 2.
Mm-hmm. So in this case, we're going to add the blue area with the green area. Okay. So, and we have all the information. Because remember, we also have the benefit of knowing that since R is 12, well, we know that that's 12. So basically base is 12, H is 12. So I have all the information I need. So I'll be able to prove to you that if I input everything, I'll come up with this math that's right here. And then from my then math, I can go ahead and give you the solution. Now, in this case, since they wanted to leave in terms of pi, notice what they did. They left everything like this because that means that when you get to this point, I can't do anything there. So I just leave it next to each other. All right, good. Okay, now, same thing for Marcus and Celeste. Look at B. Do any of you two kids know how to solve for B?
Yes.
Okay, tell us, Marcus, what would you do?
So, well, it's just a circle and a square. And we're trying to find the square's like shaded part. So you would take out the circle from the square.
Okay, so basically you're going to
Find
subtract.
the area of the circle and subtract
Yes.
it by the area of the square.
Excellent.
Okay.
All right, yes, that's exactly it. And this is what really they're doing right here. Kind of, you see how they place A's right here? They put down A's because they're trying to say area of the square minus the area of the circle, which gives the shaded area. And so in this case, we'll do base times height minus the area of the circle. So since we know the radius is 3, and for those that are wondering how you came up with 3, well, we took the 6. You know, the 6 is the diameter. This is 6, so this means this is 6. So that means if you cut it in half, you get the 3. So let's continue solving this, and we'll see that if we're going to leave it in terms of pi, we're going to leave it in this format. 36 minus 9 pi. All right, good. Okay, good. Hey, listen, that was, I think, our last example. There's one more over here, but I would rather just for us to stop there. Let me see if there's another page. No, that was it. Okay. Hey, listen, I want to thank Celeste very much for helping me out in doing this third video. Marcus, love the fact that you're here helping me do this video. And everybody at home, go ahead and write these notes and then go ahead and upload them for me. Remember, you will gain mastery when you're able to remember and understand. And you know you gain mastery once you're able to do this without even looking at the video or writing it down. You got to be able to remember, analyze, and recall in order for you to be able to say, I got mastery for this. Okay, so once you get there, you're good at this. All right, thank you, everybody, and have a great, great week. We'll be in touch.
I'm only using one Lego Max.